Hi everyone. Today we're going to take a look at scatterplots and correlation. And one of the first things that we need to know about a scatterplot is that it is now an example of a two-variable statistical graph. And I can spell stats. So we're going to be taking a look at two-variable statistics. Really what that means in the basic sense of things is we've got two variables. I'm going to call them x and y. And let's say that x is hours of studying and y is your grade. Now, some people might make the suggestion that the more you study, the higher your grade is going to be. So we might have things like 0, 1, 2, and 3. Let's say this is for an exam. And we'll put in test scores. Somebody studied for 0 hour, and the average test score, let's say, was 87. An hour was 91. 2 hours was 90. 3 hours was 94. So just as an example of what we could be looking at. Typically, we talk about two variable stats like this. We're looking for a couple of things. One thing that we usually talk about is whether or not a variable is an explanatory variable or is it a response variable. Now, this isn't always going to be something that you can find when you're looking at this, but I described this situation. I think that the number of hours you study will have an effect your final grade. Now, when I think about it this way, the number of hours is the explanation for your grade. The final grade is the response. Okay? Sometimes we refer to these as dependent and independent variables. What that means is that my response variable is usually thought of as a dependent variable. Your response depends on what happened, and so that makes the explanatory variable independent. Not all studies are going to really have that kind. You're not always looking for a relationship and explanation and response. Sometimes you're just looking for whether or not there is some kind of connection. That connection I'm really going to refer throughout this section as correlation. And that's one of the things that we're looking at is there a correlation between these two things? So let's just really quickly show you what a scatter plot looks like. So I'm just going to copy these things. And we'll paste that here. So just a quick scatter plot. We almost always try to put the explanatory variable down here. And if you think back to algebra, this is usually your x-axis anyway, so that's why our x is typically our explanation, whereas on the y-axis, we usually try to put the response variable. So remember, this is our independent variable and our dependent variable. All right, for something like this, I would be having my explanatory variables 1, 2, 3. So here's 0, 1, 2, 3. And I've got scores in here, and I'll just put kind of a generic ones up here, 80, 90, and 100. All right. So a scatter chart is probably one of the most basic charts that you will put together. 0 had a score of 87, so I'll mark that here. 1 had a score of 91. 2 had a score of 90. And 3 had a score of 94. Now, when we start to talk about correlation, what we're looking for is there some kind of pattern here? All right. When I look at this, it does seem, with just this small amount of data, that there is going to be a pattern that's going in this direction. We're usually looking for that kind of line that comes out of this. But a lot of times our eyes are going to be a little bit deceiving. So here's an example of a picture, and we'll talk about the correlation numbers in just a second, but here's an example of a picture of a number of different plots. Again, you can kind of think of each one of these as graphed on some sort of axis, where here's my explanation and here's my response, or just the two things I'm comparing. You should notice that in some of these, it's really hard for me to tell what kind of pattern it is, and some are not. Like down here, this one definitely has the shape of a line. When I look at that just visually, I say that's a really strong association or correlation there. Whereas when I look at the ones at the top here, I can't see a pattern. I could draw a line there and you'll see half the dots above or below it, but maybe someone else could come through and say, yeah, but I think this line tends to look like it's going this way. You know, half the data is over here and over here. You could have it going this way. I mean, in this case, I'm really stuck. Like, what in the world is the pattern? Each one of these, you will notice, has a correlation that's listed as R. All right, and I'll show you the formula for that in just a second. But keep in mind that all correlations are between -1 and +1. All right, so you won't see a correlation score that's lower than -1 or greater than +1. So if you look at all of these, you'll see that they're all between there. The positive and negative, thinking back to algebra, just talks about the direction. It's a positive correlation if it's going in this direction, basically up. It's a negative correlation when we think of it as going down, and so each one of these kind of is starting to give a better picture of something going down. So that's the difference. The other thing you're going to notice is that the closer to 1 or -1 you get, then the stronger the correlation is. All right, so this one I mentioned before, really strong correlation, and it is really close to -1 if you look at the R score. This one, maybe not as strong, a little bit more scattered, but still really a strong correlation. Here's one that has a correlation of a +0.5, a -0.7, and you'll notice -0.3. And hopefully as you look at these, you notice that the grouping of all of this data seems to get tighter and tighter to that line as we progress towards closer to the actual one. Now, don't be alarmed because it depends on the data you're studying. If you're working in something like psychology, you know, having a correlation score of 0.5, we might always think of that as like 50%, and we might say, well, that doesn't seem very strong. In different areas of study or different application, this is really strong. And the example I always use is in psychology. It's hard to predict human behavior. So having a correlation of 0.5 might be a really strong correlation for human behavior, but maybe it's not strong enough if we're talking about whether or not a proposed drug is going to increase a lifespan or reduce pain or whatever it is. We might need to have a stronger one for it to be acceptable. So the context of the study really helps also define that strength. So these numbers are just to help us kind of view things and not have our eyes play tricks on us when we're talking about correlation. So I'm going to show you what correlation looks like, and hopefully then you'll see why we use software to do that. And then in another video I'll show you how to use the software to do a correlation. But this is the formula for correlation. And if you remember, it's going to look very similar to the standard deviation formula. But it actually includes the standard deviation. So just as a review, to find the standard deviation of a number, I have to take the square root of every single data point minus the average, square it, and divide it by how many data points I have minus 1, and that accounts for error. So in this example that I was using before, and I'll put it down here, in this example, I would have to take each one of the x's, and I'd have to find the average, I have to take 0 minus the average and square it, 1 minus the average and square it, 2 minus the average and square it, and so on. Divide all of those, or add them all together. And I should have put the sum in here. I forgot that. The summation of it. I have to add all those together. So the average here, 0 plus 1 plus 2 plus 3 divided by 4, we'll just say 6/4, which is like 1.25. But anyway, you'd have to do 0 minus that, and 1 minus that, 2 minus it, 3 minus it. You'd have to take all of those things, each one of them, and square it. And then you would have to add them all together. And then you'd have to divide it by n minus 1, which is 3 in this case. So all that stuff, just to do the x's, you would have, and that's just to get the standard deviation of x. So we use software for it. So you'd have to find the standard deviation of x. You'd have to do the same thing to find the standard deviation of y. And then we would have to go through this, which means we would have to do almost the same thing over again. We'd have to take each one of the x's minus the average divided by the standard deviation. So this number minus this number again divided by this new number we found out. And we would have to add or multiply that times the y. So with the 0 I would do that, and then I do it with the 87, and I would subtract them, divide it by the standard deviation, multiply those things together, and that just gives me the very first one. And then I have to do it again for the second ones, and I have to multiply them and add it to the first ones, and I have to do it again for the third and the fourth and the fifth, and you could see that this would become a mind-numbing chore. So we will be using software to find the correlation. So what's really important for you to remember about that correlation is we're looking for the strength or the association between two variables. It kind of helps us measure something with a scatter plot, and we can tell whether it's a positive or a negative association, and we can see that the closer we get to one, the stronger or the more compact and fitting to a line something is. So I will put together another video that shows you in Google Sheets how to do the correlation and draw those scatter plots.